Night comes slowly to the earth, as it always has. Stars blink awake one by one, spreading their quiet glow across the sky. For thousands of years, humans have looked up at that sky with wonder long before rockets, laboratories, or satellites. This story begins not in a high-tech facility, but in the ancient world where the first spark of curiosity lit the path we still follow today. It begins with a question whispered across centuries. How far does the night go? Long before telescopes existed, ancient people watched the heavens. The Babylonians carved star positions onto clay tablets. The Egyptians aligned pyramids with Orion. The Chinese created astronomical records that stretched for thousands of years. But among these early watchers, one figure stood out: Hipparchus, the Greek astronomer who mapped the stars with astonishing accuracy around 150 BCE. He had no metal instruments, no lenses, only the naked eye and a simple device called an astrolabe. He discovered Earth's wobble precession by noticing tiny shifts in star positions over many decades. It was humanity's first true scientific step toward understanding the sky. He did not know it, but his work would someday guide spacecraft across the solar system. The night deepens. The world becomes quiet. We drift forward in time. The year is 1609. Galileo leaves a crude handmade telescope toward the moon. The device is small, blurry, imperfect, yet what he saw that night would forever change our place in the universe. The moon wasn't smooth. It wasn't a perfect, divine sphere. It had mountains, shadows, and valleys. A world, a real place, a destination. He turned his telescope toward Jupiter and found 4 bright dots dancing around it. These moons, Io, Europa, Ganymede, Callisto, proved that Earth was not the center of all things. Many were terrified. Many were angry. But something important had begun. Humanity had opened a door, and once opened, such doors never truly close. Let's fast forward to the late 1800s. A Russian schoolteacher named Konstantin Tsiolkovsky asked a question no one had dared to seriously consider. Could humans ever leave Earth? He studied physics late into the night, long after his village fell asleep. He wrote about metal ships soaring into the sky. He calculated the mathematics of escape velocity. And then he made a discovery that would shape all future space travel. Liquid fuel rockets could reach space. He never built one himself, but others soon would. In the early 1900s, 3 key individuals turned rocket dreams into rocket science. Tsiolkovsky was the theorist, Robert Goddard was the engineer, and Wernher von Braun was the builder. It was Robert Goddard who launched the first liquid fuel rocket in 1926. It rose only 41 feet, but it was enough. The silent sky had been touched. It is October 4th, 1957. Somewhere high above the Earth, a small metal sphere begins to beep. Beep, beep, beep. Its name is Sputnik 1. The world below changes forever. That tiny beeping sound becomes a heartbeat echoing across nations. It represents the moment when Earth finally releases one of its creations into the great blackness beyond. 1 month later, Leica the dog becomes the first living creature to orbit the planet. She does not return, but her mission paves the way for human spaceflight. And then, in 1961, Yuri Gagarin's voice crackles through radio speakers. I see Earth. It is beautiful. For a moment, humanity becomes one united by a man floating far above borders and wars. The moon waits in silence. Neil Armstrong's foot presses into lunar dust, older than all human civilization. A small step, a giant leap. The world watches through static-filled screens, holding its breath. Children sit cross-legged on living room floors. Scientists cry softly in the background. Humanity stands on another world for the first time. But this story is not about the moon landing alone. It is about something quieter. The moment humans realized the universe was within reach, then came the age of spacecraft that would leave our solar system. Voyager 1 lifts from Earth with a golden record aboard full of music, greetings, and the hopes of an entire species. It flies past Jupiter, Saturn, past the edge of the solar wind, then into the cold, silent gulf of interstellar space. It becomes the farthest human-made object in history. Even now, decades later, it continues traveling slowly, quietly, endlessly. A message in a bottle, drifting through cosmic waters. But this entire story is not just about machines, discoveries, or achievements. It is about a single event, small, forgotten, yet the spark that changed everything. A discovery made long before modern telescopes. A discovery hidden in plain sight. A discovery that scientists, for centuries, did not fully understand. Its name, the first light, not starlight, not sunlight, something far older. In 1964, two radio astronomers, Arno Penzias and Robert Wilson, were trying to remove a strange noise from their antenna. It was soft, steady, and came from every single direction in the sky. No matter where they pointed the dish, the noise remained. They thought it was birds, then dust, then machine interference. But it wasn't any of those. It was the oldest light in the universe, the cosmic microwave background, the afterglow of the Big Bang. The moment they realized this, space science changed forever, because this faint whisper of light proved something extraordinary. The universe had a beginning, and not only that, it left behind a map revealing how galaxies formed, how stars ignited, how everything came to be. This is the event that ties all our space exploration together, the event at the very heart of this story. Without the first light, there would be no telescopes searching the deep sky, no satellites mapping cosmic radiation, no understanding of how the universe evolved. Every rocket, every mission, every dream traces back to that discovery. Since then, space has revealed itself slowly, gently. We learned that the universe is expanding, that dark matter shapes galaxies, that dark energy accelerates that expansion, that black holes can mend space itself, and that exoplanets are everywhere. We learned that life may be rare, or it may be common. Each revelation brings us closer to answering the question ancient watchers once whispered: how far does the night go? But here is the twist, the part no one expects, the part that changes the meaning of everything that came before. A discovery made only recently, a discovery that returns us to that first light, the ancient glow from the beginning of time. Scientists analyzing new, high-resolution maps of the cosmic background found something strange. A pattern, a repeating structure, something that should not exist in a random universe. At first they called it noise, just like Penzias and Wilson did. Then they thought it was equipment error, then data corruption. But it wasn't. It was intentional. A signal encoded in the fabric of the oldest light. A message written not with ink, but with the temperature fluctuations of the cosmos itself. A message that predates stars, predates galaxies, predates everything we know. A message that simply says, we were here. Humanity does not yet know who we refers to. A prior universe? A civilization older than time? or something else entirely. But one thing is certain. Our exploration from ancient astronomers to modern spacecraft was not a journey into emptiness. It was a path toward a truth, waiting patiently for us at the beginning of time. So as you go about your day, remember, the universe is not silent. It has been speaking to us since the moment it was born. We just finally learned how to listen. And perhaps, when our own civilization is long gone, when Earth is quiet and the stars have shifted, someone else will detect a faint whisper in the darkness. A soft, gentle signal. A cosmic heartbeat. Our message: we were here. Thanks for watching. If you enjoyed this journey through time and space, consider subscribing for more stories that explore the universe and our place in it.